Here we are again. We're looking at triangles, and in the third Kahoot question, I basically challenged the student to be able to find out if they understood what one would have the biggest height. The scenario is the same. We have these two side links, 12 and 15. We have the angle between it is 50, or it could have been 90, or it could have been 105. Okay? And since I've already written this program to do this for pretty much any angle and any side links, I figured it would be a quick and easy like addendum to the question. And it asked some of those higher order type questions that you kind of have to know what you're doing to answer, and you just can't just randomly pick an answer and get it correct. I didn't give a fourth option. I mean, I guess I could have, but having an acute angle, having a right angle, and having a obtuse angle for the angle between gives you lots of potential to have a discussion about the question itself. And sometimes you ask a question so you get more questions. So here we are again at my Kahoot, at my TI Inspire like applet, and we've got this. We're ready to go. There's the area, but we're not asking about the area in question three. We're asking about which one has the largest height. Um, I don't know. Maybe somebody could have came up with the answer like logically, which one would maximize the height, acute, a right, or a obtuse angle. I think math people would know. I think advanced kids might be able to figure it out without being able to do the math, but it's nice to have the math to back it up. And since I already talked about this in the triangle one example, where we were looking for the area and the heights, everybody should know that this is going to be 15 times the sine of 50. Okay, so I'm going to show it. We go through there. The height related to AB is 11.49. It's slightly different than the example there. We had 49 before. We have 50 here. So it's not surprising. It's only a couple like hundredths off from what the other one. It's 11.5 if you're going to go to the tenths place. I like doing two decimal places when you ask for three decimal places. That way you can really show a kid why it rounded up or why it didn't round up. Okay, we go through all this stuff down here. It's a good chance you can reinforce what we talked about SAS. But that was one of three scenarios. So in scenario one, the height related to AB is about 11.5 when you have the acute angle 50 degrees between the side 12 and the side 15. We're still talking about side angle side relationships, so this triangle fits the bill. All right, now I'm going to turn this off again, and then I'm going to say, okay, what do you think, kids? Which one do you think? Do you think 90 degrees is going to be bigger? Or do you think 90 degrees is going to be smaller if we put that right here? Will the right triangle have a bigger height? So off screen, I'm editing on the little file. I'm changing this to 90, and then there, lo and behold, I've got a 90-degree angle, and you can tell because you watched it happen dynamically that that height got bigger. I'm still not 100% certain that the 105 won't be bigger. I'm trying to bait people into picking that solution. The people who are in the know that that perpendicular is probably going to be the winner. And then let's just take a look at the answers. Okay, it was 15, and then I didn't write the program, so it would not help connect it. You can kind of see this dotted pink line over the blue line, which signifies that your heights were the same. It also shows you that, look, I've got a really nice height here because I had a really nice angle. Okay, and the area of the triangle is really nice because when you have right triangles, you have that messy, pesky sine function in there screwing up your triangle. So in this case, when you have 90 degrees, because everybody knows the sine of 90 is 1, your actual like hypotenuse, not really a hypotenuse, is a leg. All right, so we got to remember, okay, the first one lost. The acute angle lost to the right triangle. Okay, now, well, if 90 degrees made it bigger, well, then 105, of course, is going to be the best answer. And then some people are going to make that decision unwisely. But I'm going to turn it off. And then I'm going to go off screen and I'm going to change it to, I think the last angle was 105. Okay, I wanted to keep it close to 90, but more bigger than like 91. Okay, there we go. I did the triangle. Oh my goodness, I want to change my answer already. Okay, because I didn't change like the viewing window of this at all. You could see that actually the exterior height has got to be smaller than when it was actually a right triangle. Okay, and for those that don't believe me, okay, well, look, the area got smaller too. That's a place where you could have had a discussion. Well, why did the area get smaller? What is the most optimal triangle out there? If you don't get to get an equilateral triangle, what should your second choice be? Okay, and then like I don't want to hold any suspense there, and maybe I should have thought about like the viewing window of this beforehand because those overlap, and that's irritating to some people. I changed the name of the exterior height to CE. If you remember from previous video, the interior height was CD. I did that for a reason. I want you to know that there's lots of heights out there. I just every time that it goes on the outside, it's CE. Okay, we get this 14.49, which is definitely smaller than this 15. So for those of you who are wondering the answer on your Kahoot, which one was correct? The correct answer for the triangle that has the largest height would be the right angle. The right angle in between gives you the largest height. Thank you for watching my video.